Okay, let's dive into a framework that's really making waves in how developers are building with large language models. We're talking about LangChain.
Yeah, it's definitely a big one.
And for this deep dive, we've got some great source material. We're looking at the main LangChain GitHub repository, also a tutorial repo by Grip Kamrat, the official docs, of course, and an overview from the Pinecone AI handbook. So quite a bit to chew on.
Absolutely. And it's needed because, anyone who's tried working with LLMs knows they're amazing at generating text, but building a real application around them, that gets complicated fast.
Right. Like, how does it access current information? Or remember the last thing I said? Or actually, do something useful?
Exactly. That's the challenge LangChain tries to tackle.
So our mission today is basically to unpack all these sources and cut through that complexity. We want to get a solid handle on what LangChain actually is, why developers are using it, its main parts, what you can build with it, and the whole ecosystem around it.
Think of it as a shortcut to understanding this really key AI framework.
Perfect. Let's peel back the layers then. So starting right at the top, based on these sources, what is LangChain? What's the fundamental idea?
Okay, so all the sources really converge on this. LangChain is a framework. It's specifically for developing applications that are powered by LLMs.
Right.
And its core aim, something the main repo and docs really emphasize, is building what they call context-aware reasoning applications.
Context-aware reasoning. I like that. It sounds like more than just, spitting out text. It's about understanding the situation.
Precisely. Giving the AI the context and tools it needs to reason effectively about the specific task or information you give it.
Okay.
And the framework tries to make that whole life cycle simpler, from development to production to deployment.
How does it actually do that?
Well, it helps you connect or chain together different building blocks, components that are designed to work together. It provides these standard interfaces for models, for embedding things, for vector stores.
So like common ways to talk to all the different pieces you might need?
Exactly. And the docs mention it integrates with hundreds of different providers already, so lots of options.
Okay, so it's like the glue and the instruction manual for building these smarter LLM apps. But why this framework specifically? What makes developers choose LangChain over, say, just coding directly against an API?
Good question. The sources highlight a couple of major benefits. First, and maybe the biggest one, is enabling real-time data augmentation.
Meaning getting current info into the LLM because they're trained on old data, right?
Exactly that. LLMs have a knowledge cutoff. LangChain makes it much easier to connect them to live data sources, the web, your company's database, internal documents, whatever. The docs really push this vast library of integrations.
So that helps deal with those hallucinations or just outdated answers. You feed it the right context first.
Precisely. It's the foundation for retrieval augmented generation, or AIRG. The model retrieves relevant info before it answers.
Got it. What's the other big advantage?
Model interoperability. The way LangChain is built, with these abstractions, means you can swap different LLMs in and out more easily.
Like try GPT-4 today, then maybe Claude tomorrow without a massive rewrite.
That's the idea. The whole field is moving so fast. New models pop up all the time. This abstraction layer lets you experiment, find the best fit, or switch if costs or availability change without losing all your work. It helps you stay agile.
Yeah, that makes a ton of sense in this space. Okay, so it's flexible. How is it actually structured? You mentioned it's not just one single thing.
Right, it's modular. There's LangChain Core. That provides the sort of base layer, the fundamental abstractions for things like chat messages, components, the standard interfaces we talked about.
The common language, okay.
Kind of. Then you have separate lightweight integration packages, things like LangChain OpenEye or LangChain Anthropic. These just handle the specifics for connecting to that provider. Keeps the core clean.
Makes sense.
Then the main LangChain library itself, that's where you find the higher level concepts, the patterns for actually building applications. Things called chains, agents, retrieval strategies. The docs call this the app's cognitive architecture.
Cognitive architecture.
Right.
Okay. Chains and agents sound important. What are they?
They really are key. A chain is typically a sequence of steps, like fetch some data, format it into a prompt, call the LLM, maybe parse the output. A defined sequence.
Okay.
An agent is more dynamic. It uses the LLM itself to decide what to do next. Based on your request, it figures out which tool, like a search engine, a calculator, an API it needs to use, calls it, gets the result, and then decides the next step.
So it's more like a little autonomous worker using tools.
Yeah, that's a good way to think about it. And there's also LangChain community for third-party integrations that the community maintains.
Right. And I saw LangGraph mentioned too. Is that part of LangChain or something different?
Ah, good catch. LangGraph is technically separate, but very closely related. It's built on LangChain core and works smoothly with LangChain components. It's an orchestration framework specifically designed for building stateful, multi-actor applications.
Stateful multi-actor. What does that mean practically?
Stateful means the application needs to remember things across multiple steps or interactions. It maintains a state, like conversation history. Multi-actor means it might involve multiple components, maybe even different AIs or human inputs, working together in a sequence or cycle.
So for more complex, longer-running tasks where memory and coordination are key.
Exactly. Think sophisticated agents that need to plan, execute, and potentially revise their approach over multiple turns. LangGraph is highlighted as being used for production-grade agents because it enables this kind of complex control flow.
Okay, that breakdown really helps clarify the pieces. Now let's get to the fun part. What kinds of things are people actually building with all this? The sources list quite a few examples.
Yeah, this is where it gets exciting. The Pinecone Handbook mentions standard stuff like chatbots and generative question answering, GQA, but the tutorial repo has concrete code examples. You can build apps for summarization. They mention a summarizepaper.com project.
Useful.
Or question and answering over documents. This is huge. Think like ChatPDF. You upload your own documents, and then you can ask questions about them. It uses RAG, which we mentioned.
Yeah, being able to chat with your own data. That's a game changer for many people.
Totally. Other examples include extraction. There's a prototype called Core for pulling structured data out of unstructured text. Or another project that extracts tech skills from job descriptions.
So not just chatting, but pulling out specific information reliably.
Right. And even evaluation. There's an auto-evaluator project mentioned, showing how you can use LLMs to automatically test the quality of your Q&A systems.
Okay, interesting. Using AI to check AI. What about those more dynamic agents you described?
That's where it gets really wild sometimes. The Pinecone Handbook talks about AI agents using tools. The tutorial repo gives some cool examples, like an agent that can actually make phone calls to order pizza via an integration with something like Vocode.
Wait, really? Ordering pizza?
Yeah. Or Nexus GPT, described as an AI freelancer platform, suggesting agents capable of handling complex, multi-step tasks. There's also a simpler Slack GPT example for putting a bot in Slack.
Wow, okay. Agents making calls. That really drives home the potential here, connecting LLMs to the real world and letting them act. These examples really show those concepts like chains, memory, RREGE, custom tools in action.
Exactly. They show how LangChain provides the scaffolding to make those theoretical ideas real.
Now, beyond the framework itself, the sources talk about a supporting ecosystem. What are the key companion tools?
Yeah, the documentation and main repo focus on a couple of big ones. Langsmith comes up a lot. It's presented as crucial, especially when you're building agents or complex chains. It's for tracing, evaluating, and monitoring your LLM applications.
Tracing, evaluating, monitoring. Why is that more important here than with, say, regular software?
Because LLMs, and especially agents using them, can be, well, unpredictable. Their reasoning path isn't always obvious. Tracing lets you see exactly what happened, what the LLM was thinking, what tools it called, what the results were.
Ah, so you can debug when it goes wrong.
Exactly. Or just understand why it made a certain decision. Evaluation helps you measure if it's actually performing well on test cases, and monitoring lets you see how it's doing out in the real world in production. It's about observability for these probabilistic systems.
Right, observability. Makes sense.
Then there's LangGraph, which we touched on, that specialized layer for the stateful multi-actor apps.
And you said big companies are actually using this in production.
Yes, the sources mention LangGraph is powering production agents at places like LinkedIn, Uber, Klarna, GitLab. That tells you it's capable of handling serious, complex workflows that need memory and maybe human oversight points, that human-in-the-loop capability.
That's pretty strong validation for needing that kind of stateful control.
Definitely. And related to that is the LangGraph platform. This is described as a purpose-built deployment platform specifically for those complex, stateful LangGraph applications.
So not just building them, but running and scaling them.
Right. It's designed for these long-running workflows and provides tools for discovering, sharing, configuring agents, and even visual prototyping with something called LangGraph Studio to iterate faster.
Okay, so it's quite a comprehensive offering then. LangChain to build, Langsmith to observe and improve, and LangGraph plus the platform for those really complex, stateful agentic systems and deploying them. What about learning all this? Where should someone start?
The sources point to lots of resources. The official docs have tutorials like how to build a simple LLM app, a chatbot, an agent, or get started with LangGraph. They also have how-to guides for specific tasks, conceptual guides for the bigger picture, and the detailed API reference.
And that tutorial repo, it had those cookbooks.
Yes, the Cumrat repo has cookbooks. Part 1 covers 7 core concepts. Part 2 has 9 use cases, often with YouTube videos alongside. They're really practical, hands-on starting points with code.
Sounds like a good place to jump in.
And importantly, it's all open source. The sources emphasize that contributions are welcome code, docs, new features via pull requests on GitHub.
And the community seems huge now. I saw the stats on the main LangChain repo, over 109,000 stars, nearly 18,000 forks, thousands of contributors, used by hundreds of thousands of projects.
Yeah, the numbers are impressive. Even that tutorial repo has thousands of stars and forks. It really shows how much traction the framework has gained in trying to bring some structure to this whole space.
Okay, so wrapping this deep dive up, the clear picture is that LangChain, along with its ecosystem like LangSmith and LangGraph, offers this really powerful, pretty flexible way to tackle the inherent complexity of building useful applications on top of LLMs.
Yeah, by providing those standard ways to connect things, models, data, tools, it bridges the gap between the raw power of the LLM and what you actually need it to do. It gives you the building blocks for everything from, simple Q&A bots to these really complex agents that can remember, reason, and act in the world.
It feels like it's enabling that next step, moving beyond just prompting to building apps that genuinely understand context and can take action.
Which leaves you, the listener, with something interesting to think about. Consider that phrase again. Context-aware reasoning applications. What does it really mean when software can dynamically pull in relevant information, remember your previous interactions, and use tools to solve problems it wasn't explicitly programmed for?
How might that change the kinds of problems we tackle with technology, or even just how we interact with our devices day to day? What new possibilities, but also maybe what new challenges, arise when we start building systems that are truly adaptable and intelligent in this way? Something to mull over.